KL divergence. KL divergence is a measure of how one probability distribution diverges from a second probability distribution. That is, if you have one probability distribution P and another probability distribution, let's say Q, then how much does P diverge from Q? This is what you can measure using KL divergence. So KL divergence gives you a mathematical value, a quantification of how much P is divergent from Q. Where do you actually use this? That is when you have to compare two different probability distributions. This happens when, let us say, you have a real world distribution P, which is difficult to find. That is, the actual mean and variance of the distribution P is very difficult to find. In this case, what you do is you will approximate it using another distribution Q. So you will have a Q, which is an assumed distribution, and then you will approximate P using Q. In this case, you need to understand how much is Q divergent from P. Then only you will be able to understand how well you made an approximation. So in these sort of cases, in order to have a mathematical quantification of this divergence, you will use KL divergence. And here KL stands for Kullback-Leibler. Okay. So KL is Kullback-Leibler. This is what KL stands for in KL divergence. Let us understand the mathematical equation, how to calculate KL divergence, and what is the significance of this concept. First, let us consider discrete random variables. Okay. In case of discrete random variables, KL divergence of P from Q, this can be written as summation over all the values of X. So here, what are P and Q? These are the probability mass functions. Let us say X is the input. Then P of X denotes the probability mass function of the first distribution, and Q of X denotes the probability mass function of second distribution. So in this case, the KL divergence of P from Q, this can be identified as summation over all the values of X, P of X into log of P of X divided by Q of X. This is how you can calculate KL divergence of P from Q, where P and Q are two different distributions. You want to understand how much is P divergent from Q. This is what you can calculate using this formula. So what this gives is a mathematical value using which you can understand how much is the distribution P divergent from Q. The same thing when it comes to continuous random variables, KL divergence of P from Q, this can be written as, so continuous random variables, you can take summation. Instead, you have to integrate. So it will be integral of infinity to infinity, from minus infinity to infinity, P of X into log of P of X divided by Q of X dx. This is how you identify the KL divergence of P from Q instead of continuous random variables. So in case of discrete random variables, use the first equation, and in case of continuous random variables, use the second equation, right? Once you understand this, the next thing is to understand what does these values signify. If you get some particular value for KL divergence, what does that mean? Okay. So you already know what is P and Q. These are two different distributions. So in case of discrete random variables, P of X and Q of X, those are probability mass functions. And in case of continuous random variables, P of X and Q of X are probability density functions that you would already be aware of. In case of KL divergence being 0, that is KL divergence of P from Q, if this is 0, what does this mean? If KL divergence is 0, that means P and Q, they are identical, right? P and Q are identical because when you found the mathematical value, you found that P does not diverge from Q, which means P and Q are identical distributions. What if, see, KL divergence value will never go negative. The only possibilities are equal to 0 and greater than 0. What if it is greater than 0? If it is greater than 0, that means the distribution P diverges from distribution Q. How much does it diverge? That depends on the value, that is therefore KL divergence. Higher the value, higher P diverges from Q. Lesser the value, lesser P diverges from Q. There is one speciality of KL divergence that you have to understand. That is KL divergence of P from Q is not equal to KL divergence of Q from P. Why is this so? This is because, see, this just means KL divergence is not symmetric. That is, if you calculate KL divergence of a distribution P from Q and then you calculate the KL divergence of a distribution Q from P, these are not identical. The reason is it is not symmetric because it measures the relative entropy. That is what divergence does. We already learned about entropy. So entropy tells you about the information. So if there is a distribution P and there is a distribution Q, what does the KL divergence of P from Q tell you? It tells you about the amount of information that is gained when you move from Q towards P. This is what the KL divergence tells you. So if you understand, see, this is another way of understanding, that is the value of KL divergence. You can see it as the information that is gained when you're moving from one probability distribution to another. So this also means it is direction dependent. That is, when you're moving from P to Q, you're moving in this direction, and when you're moving from Q to P, you are moving in this direction. So the value of KL divergence, it is direction dependent. It depends on whether you are moving from Q to P or if you are moving from P to Q. Because of this, it is not symmetric. KL divergence of P and Q, in case you're checking it off from of P from Q or Q from P, these are different values, and it is also visible from the mathematical equation. See, if you take KL of P from Q, this equation looks like this: sigma x P of x log of P of x by Q of x, right? This is how the equation looks like in case of KL of P from Q. And what in case of Q from P? Here this will be summation over all x Q of x into log of Q of x divided by P of x. So these two are not the same mathematical values. It's quite clear. So logically, you have to understand that it is because the direction is different. It is because the information that you gain when you move from Q to P or you move from P to Q, these are different. This is logical understanding, and mathematically you can see that the value that the equation gives in case of summation over all x P of x into log of P of x by Q of x, and the other equation summation over all x Q of x into log of Q of x by P of x, these are different. So for this reason, KL divergence is not symmetric.